Alright, we are in lesson 6. Our objective for today says I will be able to subtract real numbers using addition, the numbers chant, and opposite operations. So yesterday we looked at adding real numbers that had different signs. So today we are looking at subtracting real numbers that have different signs. First thing you need to know is two numbers with the same absolute value but different sign are called opposites. Another name for the opposite is the additive inverse. The sum of a number and its opposite is 0. So that's something like -8 and +8. -8 and +8 are opposites. Another word for that is additive inverse. And then the sum of a number and its opposite is 0. That's basically what this property says. Inverse property of addition. Any number plus its opposite or its additive inverse equals 0. 5 plus -5 equals 0. Now, what we're looking at today, rules for subtracting real numbers. To subtract a real number, you want to add its inverse, and then follow the rules for adding, which we looked at yesterday. Okay? So, instead of 3 minus 5, what you're going to do is you're going to change that subtraction to addition. You're going to change the sign on that 5. Subtracting is just like adding a negative. So, for all the problems that you see today, what you're going to do is follow these steps. First thing you're going to do is you're going to change the subtraction or the subtracting to addition. So change subtraction to addition, change the sign of the second term, change subtraction to addition, change the sign of the second term. Let me zoom out a little bit, and then follow the addition rules. Okay? And remember, like we learned yesterday, the addition rules are here. Same signs add and keep, different signs subtract. Take the sign of the higher number, then you'll be exact. Those are your addition rules. So, let's practice that. We change subtraction to addition, change the sign of the second term, and then always follow your addition rules. So here we go. I've got -12 minus 21. So I've got subtraction. So what I'm going to do is I'm going to keep this -12. I'm going to change that subtraction to addition. I'm going to change the sign of the second term. Right now that is a +21. So I'm going to change it to a -21. Now I follow my addition rules. I change my subtraction to addition. I change the sign of the second term. Now I need to follow my addition rules. Same signs add and keep. These signs are the same, so I'm going to add 21 plus 12 gives me 33. So I added, that gives me 33. Add and keep. Both of these are negative, so I keep this as a negative. Same thing here. Change subtraction to addition. Let's rewrite it so we can see what I'm doing. Change subtraction to addition. Change the sign of the second term. That's a -8, so I want to change it to a +8. If you ever see two negatives back to back like this, what you can do is do this. Just cross them both and make them positive. We change subtraction to addition. We change the sign of the second term. Now we follow our addition rules. We go same signs add and keep, different signs subtract. Are these signs the same or are they different? Well, they're different. This is a negative, this is a positive. So I subtract. 19 minus 8 gives me 11. That gives me an 11. Same signs add and keep, different signs subtract. Take the sign of the higher number. Which one of these is higher? 19 is higher than 8, so we make this a -11. And there's my final answer. Okay? So change subtraction to addition, change the sign of the second term, and follow your addition rules. Let's go to the back. Alright, I've got the same thing here. I've got 3 2/10 minus 5 1/10. I've got subtraction. I'm going to change it to addition. I'm going to change the sign of the second term. It's negative. I'm going to make it positive. Now I've just got 3 2/10 plus 5 1/10. So let's add that up. Those signs are the same. Same signs add and keep. So we add them. That's a 3 and that's an 8. So 8 3/10. Final answer. Minus a negative is what we had right there. Minus a negative will always be the same. Will always be the same thing as plus a positive. Okay? Minus a negative is always the same thing as plus a positive. So since you have subtraction here, you change it to addition. Change subtraction to addition. Change the sign of the second term. Now we follow our addition rules. Same signs add and keep, different signs subtract. Are these signs the same or are they different? Well, this is negative, this is positive. They're different, so we subtract. 3 minus 1 gives me 2. Take the sign, 2/5 there. So take the sign of the higher number. What's higher? 3 or 1? 3 is higher. So that is a -2/5. All right, again, we're looking at this closure. Determine whether each statement now in example 3 is true or false. Give a counterexample for false statements. The set of integers is closed under subtraction. We got to think about all of the integers, okay? Integers are -8, let's say minus -8. Let's follow our rules. Change this to addition, change that to a positive. -8 plus 8 gives me 0, okay? Is that an integer? Yes, that was just an example. I can think of any other example. Anytime I subtract an integer, I'm going to get an integer. So this statement is true because that should say difference, not sum. Mark that out and change that to difference. The difference of any two integers will be an integer. You can think of any integer you want to. If you subtract it, you will get another integer. Okay? So that statement is true. Let's look at the last one. The set of real numbers is closed under subtraction. If you're dealing with any real number, if you subtract another real number, you're always going to get a real number. So you know that that is true. So this statement is true because again, that should be difference. Yeah. Because the not sum but difference, be sure you change those to difference. The difference of any two what? Real numbers will be a, not an, this is some misprints here, will be a real number. The difference of any two real numbers will be a real number. All the numbers we've dealt with are real. So if you subtract any real number from another real number, you're going to get a, guess what? Real number. All right? Last, and remember, it's closed if any time you perform an operation under a given set and you result in the same set that you started with, it's closed. So anytime we subtract a real number, we get a real number, it must be closed. Last one. Naip collected a water sample at a depth of 23 meters from the surface. He descended another 12 meters to collect, not to college, all these misprints, to collect a plant sample. Where was Naip in relation to the surface when he retrieved the plant sample? So he was 23 meters from the surface. That means he was under the water. That means he was below. How could you write 23 meters below? Well, you could write it as -23. He descended. He went down another 12 meters. So if he went down, that means a way you could show that with an operation is subtraction. So he went down another 12 meters. So now I've got -23 minus 12. That's going to tell me where he was in relation to the surface when you retrieve that plant sample. So, -23 minus 12. I've got subtraction. I change it to addition. I change the sign of the second term. Now I go same signs, add and keep. Okay, those signs are the same, so I add. That should give me 35, right? Let's check it. 5, 3. Yes. 35. All right, same signs, add and keep. Both of these are negative, so I know my answer is going to be negative. So that should be a -35. So, where was Naip in relation to the surface when you retrieved the sample? Let's don't just write -35. Let's write that in a complete sentence. He was... Now, how can I write a -35? If he's -35, that means he's 35 feet under or 35 feet below. So he was 35 feet below the surface. He was 35 feet below the surface. That -35 can be written as 35 feet below the surface. Box that in. That is all.